Hello, I'm Allison, and this video is brought to you by the Math and Science Learning Center as part of the Quantitative Methods lecture series. In this video, I will show you how to create a project network, specifically one of the assignment on node varieties. So the reason we care about project networks is that they help us organize tasks for special projects or events. So for instance, let's say I'm planning a party. I know that there are a lot of things that I have to do in order to plan this party. I have to set a date, I have to order food, reserve a venue, email out invitations, lots of different things, right? But these activities have to happen in a certain order, right? I know that, for instance, I'm going to have to make sure I set a date before I reserve a venue. That's what this middle column is going to tell me, is which tasks need to happen before others, right? And then I also know that these different activities require different amount of time, right? So my final column is my duration, right? So a project network is going to help us organize these tasks in the most efficient way, right? So that I can plan my party in the most efficient way possible. So we can start by setting up a simple diagram to represent the relationships between our different tasks, right? So you can see here we have our chart that we just showed on the other slide, right? So I'm going to draw a little box to represent my start. And I need to know where to start. Well, the first thing I notice is that activity A and activity E don't have predecessors, right? They don't have any tasks that have to happen before them. So I can actually start with either A or E here in the very beginning. I'm going to put the project or the task duration in the bottom of this node for each of these, just so we can keep track of that. So in figuring out what task needs to come next, I need to see which events have A or E as a predecessor. And so what I notice is that D has A and only A as a predecessor, so I can put it next in my chart. All right, I'll just draw a nice little branch connecting these two tasks, denoting that once I finish A, I can move directly on to D. All right, and so now that we have D in our diagram, I also notice that I can add in B and C, which both have D as a predecessor. So I'm going to draw two branches off of D. One that goes with B, which has a duration of 7, and one that goes with C that has a duration of 5. I can't add in G yet because I don't have F in my diagram, but I do have B and C, so I can go ahead and add F into my diagram. Notice that I have branches coming off of B and C to denote this relationship of B and C being predecessors to F. Okay. And then lastly, I can add in G, and I'm going to have a branch off of F and a branch off of E to show that both E and F must happen before G does. Great, so we've done all of our activities, so that means that we can now finish our project. Great, so from this diagram, we can see relationships between tasks. But we can actually learn a lot more information if we use a different type of node rather than just circles. So you'll see here in this node, we actually have 6 pieces of information available to us. On the left-hand side, we have our 2 givens. We have the activity name, and we also have the duration. These 2 things were in our previous node. Now the other 4 boxes are going to be found as we move through our project network. So the top 2 boxes find the earliest start time and the earliest finish time. This is the earliest I could start a task and the earliest possible time that I could finish that task. We find these by moving forward through the project network. The bottom 2 boxes are our latest start and finish time. We're actually going to find these by moving backwards through the network, meaning I'll find my latest finish time and then my latest start time. Now, it's going to make more sense how we find these once we go through our example, but just a little information to help us out in the meantime in understanding how we find these. Our earliest start time is going to be based on immediately previous nodes. So any nodes that are connected to this one by branches, I'm going to look at their earliest finish times. the earliest start time of this node will be the maximum of those early finish times, right? Because I have to finish all previous tasks before I can get to this one, right? And then my earliest finish time will just be my earliest start time plus the duration, which I'm going to represent right now as a D. Okay, so I find those by working my way forward through the network. For my latest start and finish time, I'm actually going to work my way backwards, which means I'm going to find my latest start time or latest finish time first. Right, so the latest finish is actually based on the following nodes, so nodes that happen, or activities that happen after the node we're on. We are going to want to choose the minimum of the following late starts, which again feels a little weird, but it'll make more sense whenever we're actually in the diagram. Right, the reason that is because we want to make sure we finish this activity on time so that we don't start the others too late. Right, and then our late start time is going to be equal to our late finish minus the duration, which you can see here right in this example. If our late finish time was 9, I subtract away 2 to get 7. And the same thing was true if our earliest start time was 6, we added 2 to get 8. So let's see if we can apply this node to our previously created diagram. So as you can see, this is our diagram from before, right? We've just changed all of our nodes to include the 4 other boxes, right? So that we can get a little more information, right? We still have our activity labels, right? And we still have our duration already in there. Okay, so I'm going to start by moving forward and filling in all of the top boxes first. So at the start, right, I know that I'm starting at day 0 for either of these tasks. So the first ones I come across, I'm starting at 0 days. And in order to find my earliest finish, right, I just add my duration. So I'm doing 0 plus 1, which is 1, and then 0 plus 5, which is 5. Okay. Now I can't find G yet because it's dependent upon other ones over here, but D is only dependent upon A, so I can keep moving forward with that. So our earliest start time is based on previous nodes. So in this case, it's only, we get done with activity A after 1 day, so that means that activity D can start after we finish activity A on day 1. So to find the earliest finish time of activity D, I do 1 plus 4, which is going to be 5. Activities B and C are only dependent upon D, and so that means that they can start once I finish activity D. So the earliest that B and C can start is after 5 days. Right, and their earliest finish is going to just be 5 plus 7, which is 12 days, and 5 plus 5, which is 10. Now here's where it gets a little tricky. For F, it's dependent upon both B and C being finished, right? So as I said before, our earliest start time is the maximum of the previous early finishes. What that means is that I need to make sure that both activities are done before I move forward. So if I said that F could start after 10 days, B wouldn't be done yet. Right, so I need to go with the larger of the two to make sure that both activities are done. So the earliest that F can start is after 12 days. And then 12 plus 7 is 19. Right, and we're going to take that same process with G, right? F finishes after 19 days. E can finish at the earliest after 5 days. So I need to make sure that I wait for F to be done before I hop into G. So the earliest that G can start is after 19 days. And then plus 3 will be 22. So what that tells me is that my project will take me at the very least 22 days to complete. All right, so now I'm going to work my way backwards to get my latest start times and finishes. That tells me how much wiggle room I have to procrastinate, essentially. So I'm going to start at the very end and work my way backwards So I'm going to start as though I'm on time, right? I'm going to say that it took me 22 days, which means that 22 minus 3 is just going to get me 19. So I start off this way, and I take the same process that I did going forward, now just moving backwards. So I'm going to say for the latest finish time of F and E, these are going to be based on G's latest start time, which is 19. So both of these are going to be 19. And so then I take those and I go 19 minus 7, which is 12, and 19 minus 5, which is 14. Something to notice here is that with F, it ended up staying the same in the top and the bottom, but with E, we did not have that be the case. So I'll talk about why that's important in just a moment. So now, B and C are both dependent, their late finish time is dependent upon what's happening in F. Right? So the latest that they can finish and make sure that F starts on time is after 12 hours. So we're going to put a 12 right here and a 12 right here. Right? And then 12 minus 5 will be 7, and 12 minus 7 will be 5. Again, similar situation, B matches in both the top and the bottom, but C is different. Okay, so because we have this differing here, we are going to have to think about the late finish time for D. Remember, we need it to be the minimum of the following late starts. The reason that's the case is because I want to make sure that I don't finish D too late. So, for instance, let's say I said that it could end on day 7. We would be fine for that with activity C. But if I don't finish D until day 7, I'm going to be starting B too late. Okay, and I won't finish my project on time. So I need to make sure that I go with the minimum of the late starts so that I finish early enough to keep my project on task. Right, so I'm going to finish D at the latest after 5 days. 5 minus 4 is 1. And then the same process for A. It's dependent upon D, so I put in a 1 and a 0. Great. So in this new diagram, you can see that we have more information, right? We know that we have 22 days to complete this project, right? And we can see something special about these, right? You'll notice that A, D, B, F, and G all have the same numbers on the top as they do on the bottom. What this tells us is that those activities cannot be procrastinated on, right? They have to start on time if our project is to stay within 22 days. You'll notice that that's not the case with activity C and activity E, right? I could delay starting activity E up until the 14th day, or activity C, I could delay it by 2 days, right, and start on the 7th rather than the 5th. We have a special name for activities that don't have any slack time, and that's called the critical path. So you can see that A, D, B, F, G is our critical path through the network. It's the longest path, and it's also the path where every activity has to start on time in order for the project to be completed on time. So these are some of the basics of project networks, specifically the assignment on node version. If you still have questions about project networks, please feel free to stop by the Math and Science Learning Center, and a tutor should be able to help you there.